Alright guys, here we are. New set of notes. So make sure you have paper and pencil out ready to copy. Right? And here we go. Alright, let's start with the title, like we always do, right? So, the name of these notes are called, make sure that I have the right highlighter here, yes. Angle Bisector Theorem, right? Angle Bisector Theorem. So, we talked about the angle bisector before, now we're going to talk about the angle bisector theorem. So, let us see what the angle bisector theorem says, right? So, triangle, note number 1 here, right? So it says an angle bisector of a triangle will divide the opposite side, that's important, the opposite side into 2 segments, okay, that are proportional, okay, that's another word we need to identify here, to the other 2 sides of the triangle. To the other 2 sides of the triangle. What in the heck does all of this mean? Alright, let me show you. So, let us see here. So it says an angle bisector, right? An angle bisector. So this segment here is bisecting this angle right here into 2. 1 and 2. Right? It split it. It used to be one entire angle just like this, but this segment here bisected it. Split this angle into 2 and created 2 equal angles. Right? So we know that part already. We already discussed this. But what it also does, this bisector, look what it does. Opposite sides into 2 segments. The opposite sides of this angle here, this is the opposite side right here. Right? Look, it's opposite this angle. It creates it into 2 segments, which is from here to here, which is segment C, and from the center to the other side, which is segment D. Okay, created 2 segments, okay, into 2 segments proportional to the other 2 sides of the triangle. Proportional to the other 2 sides. Well, the other 2 sides are A right here, that's one side, and B, that's another side. Now the word proportional, right? So proportional means that there's a relationship, there's a balance. So there's a relationship between these 2 segments that were created, C and D, with the other 2 sides of the triangle, A and B. So pretty much the way it works is when this segment bisects the angle, it creates a special relationship between A and C, and it creates that is equal, proportional means equal, right, to the relationship between B and D, right? So let me do this. So this A has a relationship with this C, and this B has a relationship with this D. And these relationships are proportional, they are equal. So let me show you how that works. Right? So what happens is A has a relationship with C, and that is equal to the relationship B has with D. Like that. And look at that. I can go back here, and I know B is with D, and A has a relationship with the C, And this is the proportion that we're going to use, right? Remember, proportion means balance, right? Equal. For there to be balance, there needs to be equality, right? Equal. These are equal. These relationships are equal. So this is the idea that we're going to use to solve the questions in this section, right? So let's see. Let's take a look. So let's keep in mind this idea of the relationships, right? This A has a relationship with C, and B has a relationship with D. And this is after we have the angle bisector. Okay? So let's take a look. Let's take a look at the, as a whole, right, our instructions here. So let us remember that we always read our instructions, and our instructions say, solve for the missing variable, right? So we're going to solve for the missing variable. So let's take a look at the first example here. So the missing variable here is y. So in this first example, we're going to solve for y. Okay? So let us see here first. Let us identify the angle bisector. This line right here split this angle into two, right? So it created this angle and that angle right there. But what it also did is it created a relationship between that segment and this segment with the other two sides of the triangle, right? So let us use our colors to see, just like we did here. See, A is relationship to C and B is relationship to D. So let us use colors to identify the relationships. So I'm going to say 8 has a relationship with 4, and I'm going to say that 10 has a relationship with y. Now if you notice, it's on the same side of the bisector. These two are on the right side, and the bisector again, these two are on the left side, right? Let's test that theory over here originally. So here's the bisector. These two are on the left. These two are on the right. Looks pretty good to me. Okay. So now let's set them up here. Look, it was orange over orange equal aqua. Would you say that? Over aqua, right? So let's do the same thing here. So let's do, right, this red over red, 10 over y, okay? So let's say here, we have room on the bottom here. 10 over y is equal to, well, since I started down here, over y, I'm going to start with this 8 over 4. So I'm going to say 8 over 4, okay? Now, once I do that, once I have this proportion, I'm going to butterfly multiply, or like most of us are used to hearing it, it's called cross multiplying. So y is going to multiply with 8, and 4 is going to multiply with 10, right? So I am going to use my here. So y is going to multiply with 8, and 4 is going to multiply with 10. So that gives me, let's see, 4 times 10 is 40. And y times 8 is 8y. 8y. And then here I draw my line of separation. 8y means 8 times y. The opposite of multiplying is dividing. And I get 5 is equal to y. And that is my solution. I have solved for y. There you go. So that means that up here, y is equal to 5. Look at that. I found my missing side. So now I know that From here to here is 4. And from here to here is 5. That means the whole thing is 5 plus 4, 9. The whole thing is 9, right? But that's not what they're asking us for. They're asking us to find the missing variable. And we have found y is equal to 5. Perfect. Perfect, perfect, perfect. Okay, let's take a look at the second example here. So let us first identify our angle bisector, which is that right there, right? That line. And that angle bisected our angle here, and it created that angle, and it created that angle, 2 equal angles. Right? And it also created a proportion between the sides, right? So let's take a look. So let's start highlighting. Let me pick purple this time. So I'm going to highlight this purple. Actually, you know what? No, I don't want to confuse anyone by doing the same kind of color. So let's green. So this 2 has a relationship with this c minus 1. And this 4 has a purple again. No good, no good. Let's go this one. This 4 has a relationship with this c here. Okay? So let us set up our proportion. Let's set up our fractions, right? 2 fractions that equal each other. So this time I'm going to go with this on top and this on the bottom, right? On this one, I did these bottom ones on top and these top ones on the bottom. So let's go backwards here. So I'm going to say green and green first. C minus 1 over 2 is equal to purple over purple. What would you guys consider that? Pink? I don't know. Pinkish? Pink purple? C over 4. Right? And this is when we're going to do our cross multiplying, or what I like to call is butterfly multiply. 2 times c and 4 times c minus 1. Right? So let me get my highlighter here. So 2 times c and 4 times c minus 1. Okay? So 4 times c minus 1, what I'm going to do is I'm going to write it out just like this. 4 times c minus 1. I know parentheses means times, right? Okay. Is equal to 2 times c is 2c. And here I distribute 4 times c and 4 times negative 1. So this gives me 4c minus 4 is equal to 2c. Okay, I'm going to draw my line of separation. So I have my negative 4 here. So I'm going to move this 4c over this way and make it a minus 4c. 4c and make it a minus 4c. So I have negative 4 here still on the left. A positive 2 and a negative 4 are not the same sign. So I got to subtract 4 minus 2 is 2. And it's a negative 2 because 4 is bigger and 4 is a negative. C. And the opposite of multiplying by negative 2 is dividing by negative 2. So I get negative divided by a negative is a positive. 4 divided by 2 is 2 equals C. And there you go. Look at that. Right? The question said solve for missing variable right here. The variable on this second problem, was C. And I have solved for C, kiddos. Look at that. I have solved for C. I know what C is. Right? C is equal to 2. So technically, this would be 2 here, right? C is equal to 2. And this would be, C minus 1 would be 2 minus 1, which is equal to 1. So from here to be here would be 1 plus 2. The whole thing would be 3. Right? But that's not what they're asking us for. They're asking us for solve for the missing variable. We solve for C. Okay, there you go. That's 2 examples right there. Right? Let's do one more example here. So first thing we always do is we identify the angle. Go a little thinner there with that one. We identify the angle bisector, which is that line right there. So that line split this angle into two, right? Which was this angle and that angle. But it also created relationships with sides, right? So let's check out those relationships here. So let's go with this green here. So this 17 has a relationship with this 2h. Okay. And we're going to say this 15 has a relationship with what? I have no number there. How do I find that number? Well, they did give me a 28. They did tell me that from here to here is 28, right? But that doesn't help me because I need to know, well, how much is from here to here. So let me show you the trick. So the way this works is, I'm going to go back to my regular one here. So I know that the whole thing here from here to here is 5 plus 4, which is 9, right? So from here to here was 5 plus 4, which is 9. Well, how do I get 5 from 9? Look, 9 minus 4 is equal to, look at that, 5. So I took the total, which was 9, and I subtracted what I have, which is 4, and that gave me my missing side. So the total minus what I have will give me my missing side. So what is my total here? My total is 28 minus what I have will give me that right there. So this is, let me go with black, 28 minus 2h. Look at that. And that is my side right there. Perfect. So again, I took what I have, what they give me, the long side, minus the short side gave me the missing side. Again, the long side minus the short side gave me my missing side, right? Make sure you got this down because we're going to get some problems just like this, right? So now let's set up the proportions just like we did before. Okay, so green goes with green, 17 goes with 2h. Okay, 17 over 2h. Nope, not 24, 2h. I think I was writing a h backwards, flipped upside down. Have you noticed that? An h upside down could be a 4, right? Anyway, equals the purple over 15 over 28 minus 2h. Okay, look at that. So let us do our cross multiplying. So 2h times 15 will go here, and 28 minus 2h times 17 will go there. So let's set it up. So 28 minus 2h times 17. So I'm going to write the 17 first, and then parentheses 28 minus 2h equals 2h times 15. So I'm going to write 15 times 2h. Okay, so let's draw a line of separation. Let us remember that 17 times 28 and 17 times 2h. So 17 times 28, I don't know what it is, so let me use my calculator here. 17 times 28 is 476. Okay, so this is 476. 17 times negative 2h, I know what that one is negative 34h. 15 times 2 is 30h. Okay, so what I'm going to do is I'm going to bring this negative 34h over here to, it could be with this 30h. It's going to become a plus 34h. Okay, So I have a 476 here on the left. 30 plus 34 is 64h, which means 64 times 8, right? H. And the opposite of multiplying by 64 is dividing by 64. And that gives me h is equal to 476 divided by 64. Oops. You guys saw my music. 476 divided by 64 gives me 7.4. Okay. Nothing wrong with that. So 7, I round to the nearest tenth, 7.4. And look at that. That is our solution right here. So that's how much h is, right? 7.4. H is 7.4. And remember, we could totally plug in h right here and multiply it by 2 and 28 minus 2 times h, but that's not what they're asking us for. They are asking us to solve for missing variable. The variable here on this third example was h, and we found h. That's all you got to do. Okay? And that, kiddos, are the 3 examples of the kind of work you're going to see in this section, right? So make sure you got everything down. Make sure you write everything down. Make sure you remember your proportion, right? Your fraction here, your equal. Remember, don't be afraid of using colors, right? I use highlighters all the time. I'm sure if you guys have noticed, right? So I think highlighters give you clarity. Numbers give you clarity. And that's exactly what we want. All right. Thank you guys for being here. See you next time.